I start with introducing myself. I am Samia Slimani. I have just received my PhD in electrical engineering last year from the University of Bijaya under the direction of Professor Majdoub. I'm currently working as a test engineer by Kema Labs in Germany. And it's a pleasure for me to share with you our investigation focused on silicon insulation tilt angle impact on its performance under 1,000 hours of salt fog aging under AC voltage. For this, we have chosen this topic because the performance of insulation in general and insulator, it's the key factor for in the reliability and performance of equipment in high voltage and power transmission lines. Our objective is to find how the design of insulator, especially silicon insulator, and the inclination of their sheds can affect and impact their degradation, their hydrophobicity, their aging over time. And also their performance. At the end, why not maybe to propose a solution and to improve solution to improve our insulators. The procedure. The procedure was as followed. We took 4 samples, elastomer silicon samples, with dimensions 10 centimeter in length and 5 centimeter in width. We took 4 samples for each inclination angle from 0 degree to 90 degrees. Okay, these samples were fixed on a device which allowed deviation from 0 to 90 degrees, and itself it's placed into a fog chamber in the middle. The fog chamber was equipped with 2 atomizers installed in the opposite corner of the chamber to generate homogeneous fog. The spray rate was set at 1.5 plus minus 0.5 milliliter per hour, according to the standard IEC 62217. The salt water was also prepared following the same norm. It's obtained with adding 1 kilogram of magnesium nitrate to 1 liter of water. Okay, the hydrophobicity and the hydrophobicity of our samples was measured was determined by measuring its static contact angle using a goniometer and following the norm IEC TS 62073. It's just an example to how we measure and take our static contact angles. The roughness of sample surfaces was provided using a microscope, numeric microscope. Okay, and this measurement were done before and after aging of our samples. The leakage current is recorded using software NextView 4. It's a very precise software. It can give us around 176,000 measurements in just 1 hour over all the time of exposure to the salt fog. At the end of aging, let's say after 1 hour's exposure to salt fog and their AC voltage, the samples were removed from the fog chamber, and the visual inspection was done on all samples. The result: no burns, no tracks, no erosion was remarked on all samples. However, just slight discoloration was remarked on all of samples, regardless of inclination angle. The figure shows the roughness measured, surface roughness measured before and after aging of all our samples for different inclination angles. After aging under salt fog and AC voltage, we observed an increase in the surface roughness on all our samples compared to the virgin samples. And it's more and more important when in low inclination angles. To better show this, the influence of the inclination angle on the roughness of our samples, we did, let's say, comparison between virgin sample, so and before, let's say, before aging, and after aging for two inclination angles, 0 and 90 degrees, so the two extremities. Pictures in the link side are taken when during the measurement of roughness using the microscope numeric. And in the other side, in the right side, the pictures in 3D generated with software ImageG. It's just, I know that it's not an advanced method, but it's just to show the global or the general appearance of our samples. The samples in the vertical position after 1,000 hour exposition to the salt spray, it wasn't remarked any significant affection in their morphology or roughness. In the opposite, samples in horizontal position which resist to the aging just for 1,000 or less than 192 hours develop significant affection on their surfaces and in roughness. So this led us to say that the insulation in the vertical position is more performant than in the horizontal position. The hydrophobicity of edge insulation is showed with these curves. So for all our inclination angles, we remark a decrease in static contact angle. Yeah. Regardless of their inclination angle with respect to the horizontal. As we remarked also that the exposition to the salt fog was not the time of exposure to the salt fog it was not the same as it was delimited by the criterion. So I didn't explain before. The criterion is fixed to 2 milliamp during 2 seconds. So if the current, if the leakage current is above this value, the test considered failed and stopped. As we can see also from these pictures, the samples in a horizontal position maintain their electrical insulation properties for an exposure period to the salt fog no exceeding 192 hours. So it's the maximum that they can resist without lost their hydrophobic properties. In the opposite, the samples fixed in the vertical position was retaining their hydrophobic properties after 1 hour of their exposure to the salt fog. The leakage current, these pictures, these curves show us the leakage current development of all samples for each all samples for each inclination angle. So all samples show a progressive increase in the current with increasing exposure time to the salt fog and under AC voltage. The time required to reach the critical value 2 milliamp during 2 seconds varies depending on the inclination angle of the sample. For example, when the insulation is inclined is in horizontal position, we reached this value only after 192. But for insulation in vertical position, we reached this value after 1,000 hours. So we can say that the ensilation in vertical position can resist to the aging 5 times more than ensilation in the horizontal position. Okay, so here simple failure occurs after only 192 in when alpha is 30 degrees. It failed at 963, and it's 987 for ensilation in inclined with alpha 45 degrees, and it reached 1000 hours for ensilation in vertical position. As we can see also from these curves, we can divide all these curves on 3 phases. The first one, delimited with TF, is the early aging period. In this period or region, the current is stable, and it's stable. Okay, is stable after this point, which is the point, the transition point between the early aging phase and this transient phase. Here the current starts to rise quickly and to reach big values of leakage currents. The third phase is the final aging phase. It's when the current reach the criterion, which is 2 milliamp during 2 seconds, and after that the voltage switches off, and the test is failed. This period, the early aging period, is very important because it reflects the functioning of our ensilation. So that a higher early aging period reflect ensilation quality and erosion resistance. But samples, and here the highest value is the value, the highest period, early aging period, is found when the ensilation is in vertical position. For example, here the period is around 370 hours. When the ensilation is inclined with 45 degrees, the early aging period is around 230 or 40, and the same almost when the inclination angle is just 30 degrees, the early aging phase is period is around 190, but in the horizontal position, the early aging phase was only 5 hours. Okay, so if this period reflect the the functioning of our samples. And samples in we can say that samples in vertical position are very performant, and they reflect very resistance to aging. As a conclusion, the following key points are found. A decrease in the hydrophobicity of silicon insulation as a function of its inclination angle and exposure duration to the salt fog environment. Despite the hydrophobicity reduction after 1000 hours of aging, the samples in vertical position still retained their hydrophobic properties. Slight increase in roughness across all aged surfaces with the decrease of their inclination angle. Progressive increase in leakage current was recorded for all samples as exposure time to the salt fog increased, eventually reaching the critical value that led to them deactivation. Development of leakage current occurs in 3 distinct periods: the early aging period, the transition period, and the late aging period. Leakage current curve characterized by an extended early aging period indicates good insulation quality. Short early aging period suggests poor insulation quality and low resistance to erosion. So from all this point, we can say that vertical silicon insulation offered excellent performance and resistance to erosion and aging under salt spray and alternating voltage compared to the same insulation at a small tilt angle. Thank you for your attention.